For decades, submarines have relied on one powerful advantage: remaining undetected beneath the ocean's surface. Their silence has shaped military strategy and global deterrence for generations. But a new field of research is raising an important question. Could quantum sensing become the next major breakthrough in underwater detection? Traditional anti-submarine warfare has focused on sound. Sonar systems listen for propellers, machinery, and tiny vibrations moving through the water. But what if future sensors didn't need to listen at all? What if they search for something every steel submarine cannot avoid: its effect on Earth's magnetic field? And the sensor behind this idea doesn't search for sound. It searches for the invisible fingerprints left by physics itself. Every large metal object influences the Earth's magnetic field. Even submarines built with advanced materials create tiny magnetic disturbances. Detecting those disturbances has long been a goal of military research. Today's question is whether quantum technologies could someday measure them with unprecedented precision. Modern submarines are masterpieces of stealth engineering. Their propellers are designed to reduce noise. Engines are mounted to minimize vibrations. Special hull coatings help absorb sonar signals. For decades, staying quiet has been the key to survival beneath the waves. But silence alone may not answer every future detection technology. Earth behaves like a giant magnet. Invisible magnetic field lines surround our planet. When a massive steel submarine moves through those fields, it creates a tiny disturbance known as a magnetic anomaly. These disturbances are extremely small, but they are real. Military aircraft have long carried magnetic anomaly detectors, or MAD systems. These instruments can help identify subtle changes in the Earth's magnetic field. However, their effective range is limited, often requiring the aircraft to fly relatively close to the submarine. That's one reason researchers continue searching for more sensitive detection methods. So how do you detect a signal that's millions of times weaker than a refrigerator magnet? That's where quantum physics enters the story. Quantum physics explores how matter behaves at incredibly small scales. Scientists are now applying some of these principles to build sensors capable of measuring magnetic fields with extraordinary sensitivity. Rather than making submarines visible, these sensors aim to detect incredibly faint changes that conventional instruments might miss. It's a rapidly developing field with significant scientific and military interest. One of the most sensitive magnetic instruments ever developed is called a superconducting quantum interference device, or SQUID. By operating at extremely low temperatures, SQUIDs can measure incredibly small magnetic variations. These devices are already used in scientific research and medical imaging. Researchers are also exploring how similar technologies could contribute to future sensing applications, including underwater detection. Another promising technology is the atomic magnetometer. Instead of superconductors, these devices use carefully controlled atoms, often rubidium or cesium vapor. Lasers interact with the atoms, allowing scientists to detect extremely small changes in magnetic fields. Advances in this technology could make highly sensitive sensors smaller and more practical for future applications. But if these sensors become smaller, lighter, and more affordable, who will deploy them first? Around the world, governments, universities, and defense organizations are investing in quantum technologies. Research programs in countries including the United States, China, the United Kingdom, and Australia are exploring quantum sensing for navigation, communications, and detection. While many details remain classified or experimental, one thing is clear: the race to master quantum technology is already underway. This final section will leave you thinking long after the video ends, while staying grounded in what is publicly known and what remains an emerging technology. Perhaps the most fascinating technology being explored today is the nitrogen vacancy, or NV, diamond sensor. Inside a specially engineered synthetic diamond, scientists create tiny atomic defects that respond to magnetic fields. These microscopic imperfections become incredibly precise sensors. Unlike some quantum devices, NV sensors can operate closer to room temperature, making them attractive for future field applications. Now imagine hundreds of these sensors working together across the ocean. One possibility researchers have discussed is deploying many smaller sensors instead of relying on a single large platform. Aircraft, surface vessels, autonomous underwater vehicles. or even unmanned drones. Working together could one day create a much more detailed picture of the underwater environment. Detecting tiny magnetic variations is only part of the challenge. The oceans are constantly changing. Solar activity, geological formations, even Earth's natural magnetic fluctuations create enormous amounts of data. Artificial intelligence may help future systems distinguish meaningful signals from background noise. Military technology has always evolved through competition. If quantum sensing advances, submarine designers will likely search for new ways to reduce magnetic signatures. Future innovations could include improved materials, advanced degaussing systems, or entirely new engineering approaches. Every breakthrough inspires another. So who is winning this technological race? The hunters or the submarines? Nations around the world are investing billions in quantum research. These programs extend far beyond military applications, supporting advances in computing, navigation, communications, and sensing. Quantum technology is becoming one of the defining scientific competitions of the 21st century. Despite exciting advances in quantum sensing, submarines remain among the most capable and strategically important military platforms in the world. They continue to benefit from stealth, endurance, mobility, and powerful defensive technologies. Future detection methods may change the balance, but they are unlikely to erase the importance of submarines overnight. Every generation believes it has discovered the ultimate military advantage. History tells a different story. Innovation never stops. Today's breakthrough becomes tomorrow's challenge. The underwater battlefield is entering another chapter of technological evolution. Could the next breakthrough come from technology we haven't even imagined yet? Whether quantum magnetometry becomes a revolutionary operational capability or remains one part of a broader detection network, one fact is undeniable. The science behind these technologies is advancing rapidly. The future of naval warfare will be shaped not only by powerful ships, but by invisible physics. If submarines become easier to detect, how will naval strategy evolve? Will engineers create new forms of stealth? Or will quantum sensing redefine the rules beneath the waves? Only time and continued innovation will reveal the answer. From silent oceans to quantum laboratories, from steel hulls to atomic sensors, the future of underwater warfare is no longer defined by sound alone. It is being shaped by physics, engineering, and human imagination. Here on War Tech, we explore the technologies transforming tomorrow's battlefield. If you enjoyed this documentary, subscribe and join us every Tuesday and Friday as we uncover the world's most advanced military innovations. Until next time, stay curious, stay informed. Welcome to the future of military technology.